Hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. We are, I think, at the point where we're going to try and, turn the crank on the lighting. We've gotten to the point where the Octahedral light maps are actually working quite nicely. There's one thing in there that looks a little suspicious to me, just in terms of the results, that I'm not sure. I mean, I don't actually know whether it's a problem or not. And more specifically, I don't actually know whether it's a problem with the octahedral lighting or just something like a problem with our light calculation in general. But there is a certain quality to the light map result that looks a bit cube-like. And I think that probably warrants some further study. But other than that, I feel like the octahedral lighting is actually working quite nicely. It was surprisingly good once we remembered to actually turn on bilinear filtering for the samples. Somehow I just, when we were looking at it, forgot to turn that back on once we got everything working. And once we turned that on, it was like, oh, wow, this looks actually really good. So I think what that means, at least for today, I think what I'd like to do is start to tighten up the actual sort of data flow pattern that we've got in there right now. And I have a pretty good idea of how I think I want to do that, and I'll kind of walk through that first. But basically what I want to do is have done tons of experimentation with the lighting system, so it's kind of just a mess at this point. And now that I'm seeing the octahedral maps, I'm fairly high confidence that that's what I want. I like the way it's looking. What I want to do now is just kind of take a comb and sort of smooth out the lighting system so that it's, fairly minimal and just doing things the way it will do them for the octahedral maps. And so the very first thing I want to do there is just make sure that I'm writing directly into the octahedral map at all times. So right now what we're doing is we're doing a process where we actually create like a secondary buffer, right? And then we put it into the octahedral map. I think we probably want to do something where we're operating directly in the octahedral map as much as possible. And that's actually a fairly tricky thing to get right. We're going to have to spend some time getting that right. And the reason for that is, while it will be fairly straightforward, I think, to get our system updating the octahedral map directly for the actual lighting computation, because it's very simple. We just say, look, here's where you're looking in the octahedral map to write this thing or whatever. We do have to fix the code that does the in-place block copies. So if you remember, when you move around the world, we need to preserve the light maps. So when the center of the lighting system, moves around, we need to move the octahedral map so that it aligns with the move in the world, because we have effectively infinite size worlds for all intents and purposes. So we can only store the light map information just around where the character is. We can't afford to store the light maps for the whole world. I guess even if we did want to store them, we would still need to do something like this in order to keep track of where each piece was going to be. So what we want to do is make it so that we just update that map, the light map, in place, right? And we've already got codes that's doing that for the voxel version of this, but what we want to start doing is just getting rid of that voxel, right? Because the voxel is now unnecessary. We've got a flattened atlas version of this thing. That's what we're using for sampling, and since we're using that for sampling, that effectively means that we don't want to store this other representation that just costs us a big copy all the time for no reason. We'd rather just keep the thing that we actually care about and make that be how we get our data, right? And how we keep our data preserved. So I want to try and move to that. And I want to do that in a couple steps. And then the other thing that I want to do is I want to start putting in the actual light convection. So the actual thing that actually does the lighting, which we have in there, but we haven't actually sort of hooked up yet. And so we kind of have a bunch of things to do there. And I think what I'm going to do is, since the lighting looks reasonable at the moment, I think maybe what I'll do is I'll push on the second one of those first. So let me try to wire up the actual bounce-based lighting. See if we can get that looking reasonable. And then after that's done, we'll try to move from that system, which is working directly on the voxel representation, to one that's working on the flattened representation. And that, I think, will then conclude everything we need to do with lighting. Maybe there's an optimization pass that has to happen there, but pretty much that would be it. So I think we're getting close. And that's good news, because lighting is extremely hard and takes a long time. So it's pretty encouraging to think that we might be getting somewhere on it. Something that's actually reasonably good looking. Let me first open up the game here, and just do a quick run so we can see what I'm talking about. So here you can see the lighting with the actual diffuse colors turned off. So we're looking at just the light solution here. And of course, our lights currently, we have only turned on one light that we're looking at as a test. It's not doing an actual lighting computation. We're just testing the voxel, we're testing the octahedral light maps to see what they look like. And you can see I'm drawing the octahedral light maps down in the corner here. You can see that they've got interpolation turned on. That's why they kind of look, that kind of blurry look, right? We're zoomed in on just one section of them over in the corner. And so this is just a test of just a basic light source, right? And the light source is like hovering right about here. In fact, I think, is that it? Yeah, it's this one right here, right? And so, if we kind of look up here, the bounce that we're getting, it goes like, it hits here and comes up towards us. So we should always kind of see it like in this area is where we should be seeing the light, and that is where we're seeing it. We shouldn't be able to see it out here, because when we hit one of these light probes, the bounce that we're seeing is going to go off to somewhere where there's no light, right? So it looks relatively correct. And the reason I was saying there was some weirdness here is there's a couple of things that we're going to have to be aware of. So one is there's a definite like squareness to the light. You can see there's like a shadow that looks like that, like a cube shape to the lighting. And I don't know exactly where this is coming from. So that's a little concerning to me. And the reason it's concerning is not because I'm sure it's wrong, but because I'm not sure it's right. I really can't emphasize enough how important it is to, when you're looking at stuff like this, or really anything, right? When you're programming, you always want to assume that you have a bug. And one of the number one ways you can spot people who don't really know how to program is that they try to come up with explanations for why something is correct, rather than assuming that there's a bug in something. Because if you try to come up with explanations for why it's correct, you'll usually find one, right? Because computers are very complicated, and unless there's just an obvious, like the game crashes or something, right? You can usually come up with some ridiculous explanation as to why this is okay. So, looking at this thing, I'll be like, well, it's because, it's on a voxel, so obviously there'll be some square artifacts as the thing aligns with the right? Like, I can always come up with an explanation of why there's not a bug in the code. But I have no way of knowing if that explanation is actually true. I'm not proving that there's not a bug in the code. I'm just coming up with an explanation that allows me to not have to go look for the bug, right? And so what I find really differentiates good programmers from bad programmers is, excuse me, a good programmer assumes when they see something that is just a little bit suspicious, right? If there's any suspicion at all, assume it's a bug. And you have decisions here. I don't have to go solve this bug right now. I can still move on and do something else. I can even ship this with that in it if I want to. But know that it is a bug. Don't say that the code is correct when it's not, when you know that you have evidence that it's probably not, know that there is a bug there, because there may be an important quality improvement that you can make. And when you are making decisions throughout your project, you want to make those decisions knowing that there might be a bug there that you can improve, right? You can improve the quality of the software there. Deciding not to fix something because it'll be too time consuming or whatever else is materially different than convincing yourself that there wasn't something to fix, right? Because it affects the decision making that you're going to make throughout the project. So I'm not even saying that you have to fix all your bugs, because that may just not be practical for the size of the project or the amount of programming power that you have, how many man hours you have to spend on it, or however you want to measure your project size or those sorts of things. It's entirely possible that this may be a bug that we just can't ever fix because we don't have time, or any of those sorts of things, right? That's fine. But don't convince yourself that something's working properly, because convincing yourself that something's proper when you have some evidence it's not is never productive, right? That's just masking a potential problem that should be weighed against other things in terms of when you're allocating your programmer time. So I'm sorry for that big, long digression, but after having talked with Stripe this week and having experienced what it's like to try and talk to people who don't understand when they obviously have bugs in their software, and what they'd rather do is try to convince themselves that their software isn't a buggy mess, it's annoying, right? Like it's really annoying to talk to programmers who don't obviously understand that they have lots of bugs and there's tons of evidence of it. Because if they just want to say we don't care and we don't fix that because we're an internet company, so we don't fix bugs, okay, like I get it. You're trying to make money, not make good software. But trying to rationalize away obvious mistakes that are clearly there, or that at the very least you don't understand yet, so you can't say that they're correct or incorrect regardless, it's just really frustrating, and it makes it very hard to have a discussion with you, right? You can't actually get to the bottom of a technical issue with someone whose primary goal is to rationalize away that there might be a bug in there, right? So I would really encourage you to not do that, and I would always encourage you to assume that you have a bug anytime there's anything suspicious, until you have a complete pathology that you can 100% point to and say, look, I did as much due diligence as I possibly could here, and if there was a bug, I missed it, but I didn't ever rationalize it away. I tried as hard as I could to actually trace through this thing and find it out. And so, short story long, when I look at this, I know we have not done enough work to say that that is an artifact of the algorithm. We just haven't. It's very likely that it's a bug, or if it's not a bug, it's definitely true that I don't, and you probably don't either because you've only been able to see what I've done so far. We don't know what's causing it. And if we don't know it's a bug. It's that simple. So let's go ahead and take a look at what we're doing here. And I don't know if we want to take a look at this bug now, but we want to keep this test case in place because it's a really easy way to look at the bug, right? It's a very simple way for us to immediately evince this bug. And so we don't have to really, think too hard about how to reproduce it because we've got one in here now. So what I might do, just because I'm curious and I'd like to know if there's an easy way to sort of reveal what might be going on here, what I would like to do is maybe what we could put in here is some hotkeys for looking at some of the actual quantities in here. Like maybe there's some ways we can make it really fast to switch between a few different things in the lighting. Because if I could see some of this stuff, like if I could actually flip between show me the normals, show me the voxels, and so on, I might be able to pinpoint like where this stuff is actually changing, right? So that's one thing I could do, is add some more debug view to it. The other thing that I'm thinking is, as I look at what's going on here, the biggest thing that strikes me about it, right? Like the thing that is the most intriguing is that I notice it moves with the specular highlight, right? So this line, this fall off line that I'm getting here, you can kind of see like as I move around, that line moves like very smoothly, right? So remember, we're sampling this on a voxel, And if there was some kind of weird interpolation error between voxels, I wouldn't be able to place that line anywhere I wanted, right? So I'm pretty certain that we don't have an obvious discontinuity bug there, because it's actually happening anywhere you want. So it's an artifact of what happens during the interpolation of two light map samples, let's say, that actually can place this anywhere you want, right? It's where the fall off actually happens there. And so I'm more looking at something that's about why isn't there a piece of lighting information happening here? What is actually causing that sort of gap in the system, if you will? And one thing I might be able to do to make this a little bit clearer to me is, what if I took out the height difference? Because I'm getting those periodic breaks because the floor is intentionally sort of jittered around as an artistic thing that I wanted to do. If I went into the room generator and oops, that's no good. How do I need to unify my key bindings. It's hard for me to do Handmade Hero every week because it's totally not even remotely the same key bindings as my actual editor at work. So it's pretty tough. My brain always has to switch. So if I go into the room generator here and we just want to take out some of that jitter. So I think the PZ offset here that we've got, I think that's the only thing that's really, changing stuff. If we take that PZ jitter out of here, I think that would stop our floors from having any, difference. And with the floors not having any difference, it should be much easier for me to see, the lighting and the artifacts in the lighting. Now, of course, there's lots of grass there, so actually let me not go there, because that induces a pattern. Because there's a bunch of sprites laid on top of each other. So what I'd rather do here is just kind of get out to a flat room. So here you can see what's going on with the lighting a little more cleanly there, right? And you can sort of see, right? You can see more what kind of artifacts we're going to have. And you can actually see, so there's some of the things that are interesting about it, right? Is you can see on the edges how we get those dropouts for the where the zeros are for the lighting there. You can see how we get that. You get that stair-stepping pattern. The stair-stepping pattern sort of appears, I guess I kind of want to say it appears generally to be probably, roughly along the voxel everywhere, right? So I see some artifacts of the stair-stepping, not stair-stepping, of the voxel-based sampling pretty much everywhere. So that's not really surprising, right? That's what I would expect. I don't really see... to be honest, I guess I don't really see a lot of evidence that it's obviously wrong. It's kind of hard to tell. I guess I would say it's a little odd to see two separate bands moving. So one of the things that's confusing me right now as I look at this a little more carefully is I sort of feel like I'm seeing two lighting fronts at the same time. That doesn't make a lot of sense to me. So I see sort of there's kind of a hard edge here that seems pretty consistent. And then as I move this, it's like the specular, I wonder, so I guess it could be like a specular versus diffuse thing. I'm trying to think about how we're actually summing this out. But I don't think so, because we only have one lighting equation. So we are not actually summing two things, right? I guess I don't think so. Not anymore. So it's kind of weird. I don't know how I'm getting two separate lighting frontiers like that, right? And it's very confusing. Where that fall off clipping is happening, right? It's just very it's just very strange. I don't know how that's happening. And of course, you have to remember that the way we're sampling this lighting is kind of confusing, but if you think about it, what's happening is we're actually sampling it at each one of these pixels. So at every pixel, we're looking up into the voxel and we're blending between the 8 voxels that are neighboring, and we're just summing those together, right? So I'm not sure how we get like that hard edge, and then as you do this, the edge, like a secondary edge wave comes through. Like, I just don't understand that, fundamentally speaking. I don't get it, right? And so what I'm interested in doing to poke at this a little bit, to try and gain some intuition, is can I do some changes? Can I induce some structured art into this that allows me to see what's actually happening? And one of the ways I might start is I want to kind of look at the renderer itself. Not that part. So let me go to the ZVias program here. What I kind of want to do is take a look at how I'm actually computing this lighting and see if there's any particular parts of it that like scream out as I'm looking at them for if I shoved a particular known value in here, maybe I would get a little more insight, right? So for starters, one thing I could do is we're doing a ton of this. Like, here's us sampling all of the voxel locations, and then we're interpolating between them, right? So if I wanted to, I could look at just the base voxel, for example, right? I could say that instead of all this stuff, just overwrite the final one with the base voxel. And then if we look at it, what we would see is what the actual lighting computation is for these pixels, right? And so what you can see now is we get one thing we would obviously expect, which is that the lighting is now uniform throughout a particular cube in terms of some kind of intensity value that we've got there. But then we also have this sort of overlaid, like, secondary highlight that's the thing I specifically want to debug. And that gives me a good clue, which I kind of already suspected. But again, I'm trying to actually, suss out what's going on here, which is that this is, because it changes so cleanly and evenly across the things, I'm just assuming that this is the angular fall off that I'm seeing here, right? And what I'm having trouble understanding is why the angular fall off is shaped the way that it's shaped, right? I don't understand why the angular fall off wouldn't be smoother than that, why it has such a weird shape to it. But this gives me a very good indication that it is the angular fall off is what I'm looking at there. And so I want to start looking at that angular fall off to try and figure out why it's shaped the way it is, and either convince myself through enough poking that it actually should look that way for some reason, which, again, I'm kind of doubtful of, which is why I'm doing this investigation, or find the error, like find what I'm doing stupid that's causing that. Now, we don't really do anything with the lighting in here that has an angular component, right? All of this stuff is just a direct sample. So really all we do is prepare the angle, the vector we're going to sample, but all the sampling happens in here. So the only thing we can really look at in here is, are we doing something reasonable with this? So if you take a look at this equation here, what we're doing is computing the reflection vector and storing that in R. So we've got normalizer 0, we've got the I minus 2 times inner I world n times world n. It's the standard reflection. So this is just reflecting us about the world normal, right? It's like hitting the plane of the world normal and bouncing back. So that's all that we're doing here. And then we use that I vector as part of our sampling, right? Because we unwrap it into, we call it the R vector after we do that. We use that R vector to do our sampling by basically saying, look, unwrap it into the octahedral map using the inverse mapping here. and do the lookup. Now, that could be busted, or it might not be. And again, I have, I think, a good way of actually isolating that problem. When I look at the game here and I'm moving around like this, what I could do is freeze the octahedral map so that it's always getting the same sample out, because I know the normal will change throughout this thing, and I believe we do some work with the normal here, don't we? I don't know, maybe we don't. Yeah, that all looks right. So we're just going to do the basic sampling lookup, right? Yeah. So all I should have to do is freeze where I'm looking in the octahedral map, and this should all stop, right? It should get the same result. Like, I shouldn't see this. And if I do see this still, then I know something weird is up, right? So if I went and set the octahedral map's XY to some kind of a known quantity, right? Like, and I don't know where in the octahedral map I actually have valid data, so it's going to be kind of a crapshoot to find something that's not like just black, right? But once we get that, I should be able to see very clearly, yes. So once I get that, I can tell and should have a very clear no interpolation as I move the mouse around, the view around, and I don't. So that's reassuring, because it means that at least there's not some weird extra term getting thrown in there that shouldn't be there. We are actually just sampling, and off we go. So now, if I turn back on the lerping of the voxels, so I go to something that now should vary per pixel, but will not actually have any angular component to it, we should, again, just see a soft version of this thing, and that is what we see, right? We see that this blends together, and it seems relatively coherent. So I would say that's pretty reasonable, right? Like, that looks like what we would expect. So I think all of the weirdness is coming from the actual sampling of the octahedral map, and again, I don't have a good understanding of why that would be. Now, one reason might be if there's some badness in how we're doing the octahedral lookup. Another might be if the octahedral map itself has certain issues, right? That unwrapping of lighting is a warp of the sphere, and it's possible that that warp is a problem, right? I don't know. So it's not immediately possible for me to say that this is an artifact of the actual mapping to the sphere, because I really have no way of knowing. So that's a little bit of an issue as well, right? But you can see here that when I've locked it down, that weird sort of sampling went away. Now, when I unlock it, right, and I go back to where we were before, so now we're actually going to do the octahedral lookup in the correct direction. So now, when I'm moving the mouse around, I'm back to that sort of same kind of shape. So here's what I will say about it. If you look at this actual shape, it is kind of the shape of the octahedral map warping, right? And you know what? I should see if I can grab. One of our viewers actually made a really cool little thing in Desmos. You can let me look real quick. Hold on one second. All right. So Jeff Knoxs actually wrote in, one of the viewers of the show. He wrote in this calculator on Desmos that he made. That's really a good idea. He basically just made a Desmos that would show the octahedral map, which is pretty great. And so what it does, and I'll add a bookmark here for it, but you can look at that URL. It's SAYIE6XBGL on desmos.com/calculator. So if we take a look at this, and I'll put it in here as a little reminder in case we ever want to look at it again. if we look at what happens to the graph of the octahedral map, what Jeff actually wrote is pretty cool. So you can see along the sphere where you are around the ring of the sphere. So if you imagine the sphere, this is just us walking around the perimeter of the sphere, you know, from negative pi to pi, right? So just walking around the 360 degrees of the sphere, right? And then here's like the z-slice. So this is the middle of the sphere. This would be all the way at the bottom tip, and this would be at the top, right? And so what you can see is if we just make a full ring around, you can see that, like, hey, it collapses down to a point right here, which is what you'd expect, and is roughly a ring of the circle as we expand, but you can see that bowing that happens there, right? Do you see that? And you'll notice that shape is, like, really, really familiar when we see kind of this sort of thing happening here, right? You can see that we get that same kind of bowing at here and here, right, in two different directions. That curved sort of almost diamond-y shape to it. So, you know, don't really know what to make of some of these things, but it's a little bit weird. Like, I don't know if maybe there's just a artifact of how low res our map happens to be that you're just going to get some of these weird patterns as a result. Again, don't know, but can't say for sure. So again, it's pretty tough to really understand exactly what's going on there. And it's hard to say, like, to what extent that the sampling will have that sort of a boundary problem. But again, as you would expect, when you're right on the z equals 0, it's just a straight line because that's the definition of how we unwrapped it, right? We unfolded along those lines. And again, the bowing is very pronounced here and like here, right, in the map, but not here. So again, I don't really know to what extent that is playing a role in this as well. But what I would say is it's a little bit difficult for me to understand some of the patterns, right? So that pattern, for example, I guess I could believe that that pattern has something to do with the fact that as I'm looking at it, there are like copies going on, and maybe like this pixel is, you know, not filled in for whatever reason. I don't know. Again, I could come up with reasons, but I'm not confident in it. I don't have any real way of knowing what's going on there. So what I'd like to start doing is let's take a look and see what happens if we maybe play with the interpolation a little bit and see what we see. And then maybe start stuffing some specific values, some like specific color values in specific locations in the octahedral map to see whether it has to do with where in the map we are, right? Because if this was something that primarily occurred because of some way of walking through the map, we would expect to see it particularly based on where in the map you are. But if we don't see that, then, you know, obviously that's not true. Okay. So let me go ahead and turn interpolation off and see if I still see this. So I'm going to go into the OpenGL side of things. And I'm going to go to where we have the linear parameter getting set here. So in here, I'm going to change this to nearest just so I can see to what extent does this happen regardless of whether we're sampling with smoothing on or not, right? What just happened? Why did I not see a difference there? Oh, wow. So wait a minute. Oh, I'm in the wrong I'm in the wrong place. We should delete this code. This code is not even, we don't need any of this, do we? Yeah, I don't think we need any of this stuff. Yeah, these are extra like frame buffer things. We don't care about this. That's gone. I don't want to make that mistake again. We should also set a setting. Like you can see, we've got settings here. We should put some of this stuff back in. So the light sampling here, this is the one I actually wanted. So you can see me like moving around it with linear sampling there. Here's without the linear sampling. So, and what you can see is actually it's just a hard edge now, right? So you can see that it's absolutely there, but it's just a hard edge, right? So I think this is great because since we know that it's a hard edge that just turns into a soft edge later, I think this gives us a great way to start looking at this, right? Because now I'm super duper clear on where it is and what's happening. So let's try to figure out, like, is this somewhere specific in the map? Like, maybe we've just done something stupid at the edges of the map or something. So the first thing I want to do is I'm going to go in and start to knock out certain copy operations we were doing to see to what extent those play a role here, right? So if I go to the actual lighting code, right, and I take a look at that post pass that copies the edges in, what I'm going to start by doing is just when we do that edge pass, so this is the edge pass here, what I'm going to do is anywhere we were going to do a update, I'm going to put in an optional thing that instead of actually doing the correct writes, it's going to do false writes. So, for example, if I just right here, I'm doing this sort of this copy, right? And if we look at what light voxel C is, so in the game render commands, right, what we're doing is we're filling out this V3, and then this D here we're also doing, but I don't care about that because, again, we're not using the depth yet. So we're doing this light voxel C. What I'm going to do is I'm going to have like two values that I copy out. So C0, the first one, will be the one that gets copied into the first location, and C1, the second one, will be in the second location. So I've done nothing. The copy is exactly as it was, and I'm going to put in some if0 code here that just puts in some like hard-coded, full, bright color values in place. And they're if-zeroed out, so if I recompile this, I should see no change, right? And I don't. Like, that's exactly what I would expect, right? And so then what I'm going to do is I'm going to say, all right, let's actually fill these in. Now, you can see I'm not getting anything here because of where I am in the world. Let's actually back that zoom out, and let's actually see if we can get a view of sort of the area that we're actually in the texture right now. So at the end of the rendering, you know, we've got this thing that puts those in there, right? And I guess it's during the init call that we actually set those up, though. It's actually this right here. So let's actually zoom this out and see if we can see a little bit better what's going on in our texture. Let's just see if we can find a place where it's actually looking at something. And I'm going to try and find it here because you can see the center looks like maybe we're not in the right place at the moment. We got to like find where this room unpacks when we're looking at it here. So there's some. So I just want to be able to see like the part of the light map that's actually valid at this point in time. So here we are looking at the light map, and you can kind of see like that we've got a pretty reasonable part of it here, right? And as I turn around, right, the light map's not going to change. It'll change as I move because that moves the light source. But this is just changing the angle that we're sampling in. So this is just changing where in here we're actually like sampling. That's all that's happening there with that angular change. So that's sort of a separate issue, right? So now let's take a look at what we get here if I actually put in these copy overwrites. So now instead of blending that border, we're going to have like a red and green line, right, that sit there. And what you can see as I'm moving around here is like the red and green is like nowhere to be found, right? Like we're just not seeing that like anywhere in here. You know what I'm saying? And so, you know, there's a couple of things that are kind of weird about that. But if you think about it, I guess I'm not surprised because the edges, when we're not interpolating, you wouldn't ever hit the edges, right? Because we go right out to the edge here, but we never cross the boundary. So in a sense, that's actually encouraging because with interpolation off, I suppose we shouldn't see that, right? I mean, we shouldn't see that difference there, right? So let's go ahead and turn interpolation on real quick and see, because we hope to We do hope to see those, but that will also tell us, are we at that edge or not? Because I don't know. And we could also poke some structured art in there to see that as well. But you see what I'm saying, right? So if I go to the OpenGL renderer and I look for the GL nearest here, I turn this back to linear like so, and I can now see what, is there any red or green that shows up on these edges, right? And so there's nothing there, right? Like, it is absolutely not there. You can see that it is getting sampled, but it's absolutely not in that location, right? So what's most interesting about that is it means that that artifact that we're seeing is happening kind of in the middle of things, right? It's happening actually inside here somewhere. And we don't necessarily know exactly where yet, but what we do know now is it's not any of these edge things. So if I actually turn, and I might do this. So I can sort of say, let's look at the edge coloring here, right? And I'll do that like so. So I'm going to do this one exactly the same way as I did the other one. So I'm just going to put in a C0. I'm going to put in a C1. And then I'm going to put the ability to sort of color those things specifically in the middle. And so now this will also create a border on the other side. So, just in case we're getting some sampling weirdness there, we should be able to see that as well. And again, looking at what's happening here, just nothing happening without linear, which is what we would expect if we were doing our mapping correctly. Turning linear on, we should see, hopefully, nothing in this region, and we don't. So again, that sampling is really only out at the fringes. You can see it out here and here, right? But I'm not getting any of it in the actual region that we care about. So again, I think, to at least a certain extent, I would say the copy, our copy operation itself doesn't seem particularly implicated there. And right, I'm not seeing much of an implication that this border copy could really be could be any particular part of the problem. So what that, leads me to start thinking about now is that means this seam is something that's showing up during per pixel interpolation. It's based on the angle, not the location in the voxel. So the lerp is not particularly implicated here, right? And furthermore, I guess I'm wondering too, what happens if I turn the lerp off now? Oops. So if I jump into ZBias program and turn that lerp off again, I'm just curious what happens here. I don't quite remember. I apologize. I want to take a look. So if I turn the lerp of the voxel off now, what happens to that seam? Okay, so this is even better. I've now eliminated most of the code, right? So we're now just looking at this diamond pattern almost entirely separately from any other issue, right? And what's more is I'm wondering too, could I just pick a particular voxel out and go even less far, right? So for example, if I look at where I am, in the world, so here we are, and we're kind of right outside the hot region, and down. So, in terms of where we are in the voxel, we're dead center. We're pretty much dead center of the voxel, except in Y, where we're back a bit. And, well, I guess even there, we're pretty close to the center. We're almost dead center voxel, but we're a little bit forward in Y and a little bit right in X, right? So we could kind of pick whichever voxel we're fairly close to here. and just lock to that voxel and see the pattern like by itself almost, right? Now, I don't know we care because we can see it so clearly at the moment. I suppose we don't really care about that. But it's at least worth noting that it seems like what's in the voxel doesn't even matter. Because this thing happens no matter where we are, right? We're here or here or here. It really doesn't matter. We're getting this sampling on every possible voxel cell. So it doesn't look like it matters which cell we're on. The only thing that matters is that there's any light there. So we don't see any up here because there's no light for us to see, but anywhere there was any lighting at all, we get this pattern, right? So I think this gives us a really good opportunity to hunt for the bug, right? We're in a really good place. We're kind of like the cat that's sitting watching the shrub that the mouse ran into, and we just have to be patient and wait for the mouse to run out. And when the mouse runs out, we're going to pounce, right? So let's take a look at let's try and figure out some ways we can poke, let's swat our tail on the ground a little bit, if you will, to try and provoke the mouse to actually come out so we can pounce it. So looking over here, here's some things that I'd like to see. If I zoom in on some of these voxels, and, looking at this, I almost want us to be able to move around in here. Like, it'd be nice to be able to scroll this thing around, right? But unfortunately, we can't. We don't have we'd have to spend some time writing that. And I don't know, it would probably be worth it, but I don't really know. So I'm kind of tempted to say, let's just stay the course right now because I kind of feel like we're hot on the trail. I don't want to spend the time, the diversion, and possibly lose the mouse, right? So the only thing I'm thinking here is like, well, can we zoom in a little bit more on this, right? So, oops, that's not what I wanted. I wanted that. Can we zoom in a little bit more on this and just take a look at where we are in the atlas, in the lighting atlas? Could we zoom in a little bit more on this and just see a little bit more clearly like what we're looking at there? And one thing I'll note is I'm assuming this must be the wrong side of the voxel. Like, if we just zoom out even a little bit more than this, so let's say that I take that span up a little bit more. I'm assuming that we actually there's a brighter section somewhere, right? Because this looks like that looks really bright, and I'm not seeing that anywhere. So I'm assuming this is like on another Z sheet, like we're on the wrong Z sheet somewhere. Like these are Z sheets. I'm assuming we're on the wrong Z sheet or something, or maybe we're on the wrong Y sheet, I suppose is the other possibility. So I'm not sure, but I'm going to hunt a little bit for it just to see if I can figure out like where the heck this thing is actually brighter, because shouldn't it have something approximately that brightness, which is quite bright? There we go, right? I'm like, we should see something more like what we're seeing here if we expect this to actually be corresponding, right? So that's at least a little bit better. So I'm going to keep hunting a little bit. So it looks like towards the far side of the map, towards the right side of the map is where we actually see those values, right? And let me actually go all the way to the end just to see what we get there. So yeah, it looks like it's not at the very end. So it looks like 0.8 was a reasonable area. Let me just zoom out even a little bit more, see if we can't find. Yeah, you really just don't see a lot of brightness. You can see in the map right there. I can turn off the those bright colors, and maybe we should make those a little bit less glaring at the moment. But I could just turn them off entirely because now we know they don't actually matter, right? Yeah. So let's take a look. This should just turn those off entirely. So I guess, that's the brightest part of the map, presumably. I mean, I guess I don't really know. We can take a look at the other side of the map and see if on the far left side, there's something brighter, but it sure looked like the brightest stuff was at like 0.8. And we'll see. I suppose we can also zoom out even more. Right? Here's us looking at the 0.8 side of things again. So you can see that it's just like each slice, and it's like these are the Y slices, right? Because remember, Y is stacked. That's why there's multiple of these. And so, you know, I mean, which one's the brightest one? I don't know exactly. Maybe this one here. It looks like it's getting a little bit darker over time there, but that one looks pretty bright right there. Ooh, those two look particularly bright, don't they? Again, just trying to find... yeah, so it looks like maybe this is... Oops. Looks like maybe this is our jam here. Just want to get a little bit more zero. It looks like that one's maybe even better. We should probably turn off some of those extra things we're compiling for no reason now, since we actually care about the compile time. In fact, I might just go do that. So in here, we're compiling a bunch of stuff like the ping test, the sphere generator, that don't need to be, the font, the HHA editor. Like, we're compiling a ton of things. So let me just see if that improves our time at all. Yeah, I mean, that's definitely a faster compile, right? So we should probably just be on that. All right, so if we take a look at this now, we're kind of zeroing in on a nice bright one for our current location. And if I just go in here and maybe tweak this ever so slightly to try and just get that in the center, and then zoom in on it a little bit, I'm hoping that we can get a feel for what the map looks like in this area, just so we know that we're looking at the same thing. So I'm going to start reducing. I'm going to zoom in a little bit here on it, right, and try to get it so we're looking at right in you know, right in the sweet spot here. And that's just, again, just to make it a little easier on us so I can kind of see what we're looking at. And you can already see I'm going to get some good information out of this. You can see some differences, abrupt differences in the map there. So let me go ahead and zoom in a little bit more and possibly adjust. So I want to, like, I guess I don't know exactly which one of these I want to look at, but we're in a pretty good area here. So let me zoom all the way into our default zoom now, and we'll take a look. So I would say that actually that pattern right there is a pretty good indication of what we're seeing. It looks like we're actually writing into the actual map a very bad pattern, right? I'm kind of interested in that. So let me go ahead and go in one more zoom level here just to look at that a little more closely. And right, you see, like, we're writing in basically the same exact values in here, which seems really weird that we would be able to hit so precisely on that. So I'm kind of wondering if maybe we've got some kind of a weird, like, bug with how we're truncating our values or something like that. Those values should probably not have those hard edges like they're having, right? Because anytime you have, so just to be clear on what I'm saying here is, like, anytime you have two neighboring values that are the same, then when you do that interpolation, you're going to have a constant value, and then all of a sudden you're going to start changing the constant value right across that boundary, and your eye is going to see that. So it's probably the wrong time to talk about continuities. Excuse me. But here's the thing. your brain can see different kinds of continuity changes. So if you want to create a seam that you can see, a visible seam like an edge, there's actually more than one way to do it. One way is to make a large change in the actual color values or intensity, or depending on what you're doing. In this case, we're just black and white, so intensity. You make a large change in the intensity from one pixel to the next, right? And that large change in the intensity will create an obvious seam. And we have interpolation turned off right now. So as the interpolation moves from one to the other of these, right? Or from voxel to voxel, so from here to here, which it can also do, right? Like this way. A large discontinuous change in the actual intensity value will create a seam. And that's the kind of seams we're seeing here. So all of these seams are that kind of a seam. And we expect to see these kinds of seams because we have interpolation turned off, so we should see them all. But the question is, if we now go back in here, right, and I turn on interpolation, so I say in here where previously we were doing GL nearest, I go and change this to GL linear, like so. Now we're doing interpolation, so there will now no longer be one of those changes anymore, right? Now, again, we've locked the voxel, so we're not interpolating along the voxel. So, of course, that seam remains. But where does that seam come from? Why can I see that so clearly, right? And usually the answer to how you create a seam when you have linear interpolation or something like that on is because you've actually created a discontinuity one level down. So you created a discontinuity in, for example, in the derivative of something. So when it's going from one rate of change to another rate of change, right? And you perceive that difference in the two rates of changes as accelerating, right? As you see like a dip, right? Your brain sees that this is smoothly going at one speed and then suddenly going at another or something like that, right? So I don't really know if that's implicated here or not, right? But it's entirely possible that it is. It doesn't immediately strike me as that because this is interpolating out to 0. And I would have expected to see an interpolation across that boundary creating a problem as well with that. And I'm not really seeing that, right? So that's a little bit weird. I like how that we've got a little interceding cube that was causing me a problem there. So it's a little bit hard to tell about that specifically. But, off you go. So I'm not sure why I'm not seeing that transition boundary. But again, it could actually be that I'm on like one of these voxels where it's almost black here. And maybe one of these has it actually completely black, and that's the one we're actually in. In fact, where's that edge coloring? In fact, Casey says, yeah, so in fact, if we now turn off turn off interpolation and look at the actual thing. So actually, though, we probably can find one of these that does that change, right? Oh, never mind. All right. I guess that was just along the boundary. So never mind. That avenue is foreclosed, right? It's not that. Because actually, if you look, those were just boundary copies that were looking that way. So I was just confused about where we are. Glad we have this. That helps. So I'm not actually sure, right? As I'm looking at this, I'm not actually sure where that seam is coming in, right? I don't quite get it. So what I want to do now is, if I can, I'd like to poke in to some of these here, some structured values, so I can see, like, where is this coming from? How are we going from a super bright value here? Like, that's right in the middle of a voxel, right? And I know I'm not interpolating. I turned off voxel interpolation, so it can't be the voxel interpolation. That's just picking inside the same voxel, going from one thing to another thing. It went from this color to that color. How did it do that, right? So what I want to do is try to find where this actually is, right? Like, where is that actually happening? Which voxel, which atlas in the octahedral unwrapping, which one is one of the, I don't care which one. Let's say it's this one, but it doesn't matter. I find any of them. So again, structured art to the rescue. Thank you, Mike Biddlecombe, as we always thank him for structured art. If we want to take our copy, so where we're doing the edge coloring, at any time in here, I could also just poke right into the thing. Like here's a bunch of pokes right here, right? We're just like sticking stuff into the voxel. I can just do this and put some structured art into a particular pixel. So let me try to find where that's happening by using like a structured poke here, right? So I'm gonna poke bright blue in there. Or actually, let's do yellow. I'm gonna poke a yellow directly into the voxel at a particular location, right? So doing this won't do anything because this will just put it in the corner. So what we expect to see now is a bright yellow dot in the corner, and there it is, right? Maybe I don't want yellow. Maybe I want purple because I'm not using that for anything else. Let's say purple. So that'll put a bright purple dot in the corner. Then what I want to do is try to find, and I have no idea where, but I want to try and find the TXTY that would put me on one of these things. Whoa. That is not what I was expecting to see, but oh, I guess I should have. Wow. Okay. So actually, those are just the texels. Those are just the texels. That's the interpolation along the texel. Right? So basically, the problem here is just the interpolation isn't blurry enough. I mean, really, that's all we're looking at? These are just the texels of the octahedral map. So I was very right that the bowing is what those curvatures are. That's just the lat-long curves along the octahedral map. That's just what we're looking at. How fascinating. All right, so that makes me want to do the following test. So what I'd like to do is fill in the 9x9, rooted at 3, right? So I'd like to basically do this, and I'd like to start looking at our interpolator. Wow, that was fascinating. Do you see what I'm saying? Like, because I assumed there was a bug, now, even if there isn't a bug, I learned something. Like, I now know what the heck I'm doing, right? But until we actually dug in there, we really just didn't know what that was. And it would have been so easy for me to just, you know, do what Stripe does and assume that you know what's going on and totally not, and just brush something aside, right? And that's really frustrating that people do that. Never do that. You will learn something, and we just did, right? Like, we just learned something huge, and there's no question that knowing that going forward will be very important to us. Even if there was no bug here, it was really important that we dug in hard to this problem and not cheese around, right? So let's fill in a very specific matrix here of like known colors across our series, so we can take a look at that interpolator and start to think about how we might be able to improve the quality for the kind of interpolation that we're doing here. And maybe that means doing a little more sampling ourselves, which in theory wouldn't be too bad because, again, like I think we've got, because we're just sampling from one texture and we'd be sampling right inside the texture in a very specific place, we shouldn't be causing much texture bandwidth there. So I think the fact that these atlases are nicely compacted in a way that a graphics card likes to see things will allow us to do more than we would have been able to do if these were spread out in voxel land or who knows what. So if I go in here and look at what's going on, I just want to spread these out so that I can kind of get like a better idea of what's going on. So I'm going to try doing like, maybe I'll just do like arbitrary colors throughout. So maybe I'll just do like this kind of thing. Right. And I'm not really sure, again, like what the best way to do this is. Like I'm just trying to assign color values that will give me some way of uniquely identifying where I am in the map for everywhere around this texel, right? So do you see what I did, right? I just put in a 3x3, I may have said 9x9, which I didn't mean. I meant 9 pixel, 9 texel. So a 3x3 centered around the particular one that we were looking at, right? Just so I can see what happens with the interpolation, right? So again, we can very clearly see what's happening now, right? We have a way better understanding of what we're doing here, right? We can see that is the sphere being unwrapped, the sphere of lighting being unwrapped there for us. That's what we're looking at. And now what we want to do is look at what happens when we turn on the interpolation and see why it is that we can't, like, shouldn't there be some way to smooth out the way that we're doing this interpolation to not see those seams, right? And so what we're seeing in the seam is the bilinear filtering artifact, right? So what we're seeing there is we're seeing that sort of square-based interpolator coming to bite us, right? And so what we could do is try to use maybe some kind of a radial interpolator or something, right? We could try to fuzz those, to make those edges less linear and more, for lack of a better word, puffy. Right? We could try to change those fall-off curves and produce something, you know, that was a little bit more diffusing in like more of a spherical pattern, right? Because again, this is lighting on a sphere. We don't really want lines. So I think what I'd normally do at this point is I'd probably go spelunking for some papers. And I try to figure out if anyone had done stuff about how do you interpolate points in an octahedral map, or not an octahedral map, points in a map to try and get better sampling than linear. That's what I'd probably do. What I'm going to do instead, just so you know, is I'm going to try and figure it out myself. And again, that's more to show you how you might go about doing that if you're going to spend more time on it. So before looking, we're going to give it one crack ourselves, which we always try to do on Handmade Hero, not because I think you should necessarily do that in actual practice. I do think you should do that in actual practice when you're learning, by the way. I think you should always give something one go first, but then you do want to go read about it. When you're actually professionally programming, I usually do it the other way around. I usually familiarize myself a little bit with what's already been done in that space before I give it a crack myself, because you know, I don't want to go in blind for no reason. I mean, I might as well know. I try to keep in mind that I should always look for novel solutions, because oftentimes I can come up with something that might be new and interesting. But I like to know before going in what other people have tried in case something seems particularly good to me. Or also so I can sort of see, like, what are some ideas about directions I could go as well. You know, it helps. So let's take a look at this interpolation here. Looking at this, right, what I'm kind of interested in is what if I just knocked out the center pixel? So let's suppose that I wanted to look at that 4 pixel, this one right here, and I dropped it to no light. So there's no light coming from the dead center pixel, right? If that happens, you can see exactly what we're kind of getting, right? Like, you can see those lines, and these are just derivative lines. Where again, it's never discontinuously setting the value. It's just when you do interpolation in a bilinear fashion, you're going to see these derivative lines that you get in there as the change happens. You can read them. Your brain can see them, right? So I'm trying to think if maybe I could make something that didn't have that, and I just interpolate in a slightly different fashion, right? So if I just figure out a way to, produce an interpolation that didn't have that artifact, right? And so, considering it, I'm trying to think, like, what if I just did more of a radial fall off? So what if I just changed, like, how I was blending these two things so that that maybe we didn't have that particular artifact, right? And I think we could actually probably do this just by modifying the UVs. But I don't know that I want to, like, actually start with that, because that way lies, like, a very specific implementation. And since I'm trying to experiment, I would want something that I could sort of screw around with more, like something that I could actually do more like, what's the word I'm looking for? I want something where I can do more experimentation, more quickly. So what I'm asking here is, like, where we're doing this sampling here, so when I actually produce these values, I'm wondering if when I interpolate the light source here, where I interpolate the place I'm sampling in the octahedral map, I'm just wondering if I can do my own blending. So instead of this, where we do the single lookup here, which, again, we might not want, like, it's a little bit hard to give up because it's nice to have it. It's probably much faster than if I do it myself. I mean, not much faster, but a little bit faster at the very least. So I don't want to give that up if we don't get a major quality improvement. But if we got a major quality improvement, again, I'm sampling from neighbors. I'm sampling the exact same samples that the bilinear fetch probably would have sampled anyway. So I'm staying in the texture cache just like they want me to. And presumably, doing the blending myself is going to add some overhead, but wouldn't necessarily be the end of the world. Now, because I never remember what we actually have access to in GLSL3, right? I'm going to take a look and see what I've got. Oh, got that on hot. Got that on hotkey. So just looking at the texture sampling is all I was interested in here. I just want to know which samplers I have, and what kind of sampling I have to work with. So if we take a look in here, here we go. Here's all of our texture operations that we have. Is this 4 or 3? 3, good. Okay. So here's all of our texture operations. And looking at what we've got here, so this operation would probably what we would want. This would allow us to give a sampler. I assume this is just the UV coordinate, right? And then I can give a specific pixel offset. So I can sample the 4 texels in question there. I assume that's what that would do. We'll double check because, again, I never remember what all these crazy things do. I know what I want to do. Oh, actually, no. I take it back. That doesn't look like what we want. This looks like what we want because we want to fetch a single texel, right? So texel fetch offset is probably what we actually want. This basically says, well, or is it? Because this doesn't do the UV mapping for us, although I guess that's okay. But what we would like it to do is just give us do the UV for us. We're going to have to produce the fractional part for the blending anyway, so I guess it doesn't really matter. But I guess this is what we would do. So we'd call texel fetch offset, or just actually I guess texel fetch at that point, because we would be doing this ourselves. So we would just say, look, here's the offset. Here's the particular texel to sample. We'd grab 4 of them, and then we'd do our own blend of the 4, right? Just to see what different blends might do in order to sort of change the way that that sample was perceived, right? And again, this is just to see if different ways of blending the lighting would change things. So what I want to do here is I would like to be able to switch between these two things fairly cleanly, ideally. So what I'm going to try here is something I don't think we actually have ever tried before, but I think it should just work. And that is to say that since we were just passing a giant string to OpenGL, I think once we kind of do some computations here, I should be able to just do this, right? Well, actually, no, I guess that's not entirely true. I have to put this in there. Oh, you know what? No, I'm dumb. I don't even have to do that. I can just use an if0. So if I want to, right, I can still use if0. I can use if blocks in my shaders just fine. So I'll just do that. I don't know why I did the other thing. So what I should be able to do is do something I can turn on and off in here so that I can overwrite this and do our own sampling. So let's say we're going to return this result, and I'm going to do something that looks like this, right? So if one, we do the existing lookup path, right? And what I want to do is pull the A out of here because I don't care about the depth part right now. We're not using it. We're just trying to work out our lighting sampling. And then the depth sampling we can work on later as sort of an extra thing if we even want it, which we might not. Like we may decide we don't need that. If we don't have lighting bugs related to sampling things through walls, the only reason to have the depth is to prevent you from sampling from lighting probes that you yourself should be shadowed by. And that's kind of an extra level of accuracy that we either do or don't need based on the aesthetics of the game and what we perceive. It's not a yes or no thing. It's a, look, this is just sort of an intangible, what do we think? Would this help or not? So if the results are good enough when we're done with the color version that doesn't use depth, we just won't use it. So I don't want to do any work on that. That's why it's just kind of been riding along as just, okay, we can do a second texture if we want to, and we know we can, but I'm not going to try and make it sampling good or any of that stuff. So that part is just a separate issue that we'll look at later. So for right now, we just want to update this, and basically what I want here is some way of producing my own blend value. So I want to be able to take 3 different samples here of the color that would sort of be like around the horn, exactly like we were doing before, right? I kind of want something that looks like this, where we do 4 samples to get the the 4 pixels that are on the sides of where we are. And then I want to just do some experimentation to see if even without, so we could choose to sample an even wider region of the texture and try to do some kind of really much fancier job on that interpolation. But what I'd like to do here is maybe like try just doing some radial sampling or something on this, or something like that, right? Just to see if changing the interpolation curves is enough. And it might not be, right? But I just want to see if changing the curves is enough. And again, I think actually, no, we can't actually. That doesn't work with bilinear, never mind. Actually, now that I'm saying that, I think it does. So what we probably would be able to do, assuming we're doing bilinear, right? I'm assuming what we could do there is actually just go ahead and compute the UV coordinates that are the blend that would be done radially, and then just do the texture sample. I think that probably actually works. And so now that I think about it, maybe that's just fine. So let me try to do this a slightly different way. Okay. So backing this up, here's our sample CUV here. I guess I'm going to take this out entirely and say, what if we just keep doing that? And the only thing I'm going to if one in here is a thing where we take sample CUV and compute a different value for it, right? So we're just going to change how we're computing the UV that we're sampling from. I'm not actually going to change the fact that it's a bilinear sample. And let me explain why. as I gotta get the owl of shame out of the way. We haven't done anything shameful yet today. All right. So what I'm saying here is if we take a look at what we're doing here on day 580. Oops. So in terms of I'm going to call this bilinear fudge. So what we know is that the graphics card will automatically, for us, if we have a situation where we're talking about 4 pixels, or in this case, texels, and I want to sample a value somewhere in them, then what we know is it will do the bilinear blend for us, which basically constructs these 2 values and then constructs this value in theory, but really what it's going to do after all of that is it's just taking what the coefficients would have been and doing a 4-way sum, right? So it's doing something that basically just looks like, all right, the texture lookup at the end of the day at UV is going to be equal to like coefficient 0, 0 times texel 0, 0, and maybe I'll write that as a small c. Coefficient 0, 0 times texel 0, 0 plus coefficient 0, 1 times texel 0, 1 plus coefficient 1, 0 times texture 1, 0 plus coefficient 1, 1 times texture 1, 1, right? So it's just going to be a summation of this form regardless of what happens, right? It's just going to take and add up these 4 values multiplied each by some weighting factor. So it's going to compute these, and it's going to compute those based on the bilinear blend, right? But we always know that it's going to come out with a certain set of values that will do this convex combination, right? And so all I'm wondering is, can I just adjust those values? And I don't necessarily know offhand, so let me see if I can, right? So what I want to do is I want to do something like this. I want to say that the coefficient of t00, 0, right? I want to say that there's going to be like a radial coefficient. And the radial coefficient of like t00, 0, right, is going to be equal to the distance equation from this point, right? So wherever I am, I know that as I move away from this point, the furthest I could be away from it in like if a pixel is 1 wide, like there's a value there that we don't know what it is because we're not actually in UV space at the moment. I'm just talking about if this length was 1 and that length was 1. So in that space. Then we know that this length here would be 1 and this length here would be like √2, right? And so the question is like, all right, when do we want this pixel to stop influencing things? And if we were going to make it be a radial fall off, right? So it looked like that, let's say. Then what we would do is say, like, let's say the radius of this thing is 1. So what I want to do is I want to take the radius of this, right? And so if we imagined the UV in here, right? Like the U or the V displacement off of this thing. And probably I should be doing this off of the bottom one, so we're talking this way, right? So the U and V displacements of this particular one, what we'd be saying is that, look, we're going to start at 1. So if I'm right on the thing, I'm going to be fully bright. And then I'm going to subtract from there the square root of the U squared plus the V squared, which is the length of this vector. And when it gets to 1, I want this to be 0. So I want this to be a clamp, right? So this right here is going to be a clamp, meaning I'm not going to allow it to go negative, right? And that will be my equation. So I don't know how to write clamp in any particularly convenient way, but let's just say maybe it looks something like this. So I want to clamp this so that it's only going to go down to 0 and never below, right? So if we imagine that I take each of these things and I produce a radial fall off for each one of the points of light here, right? Then what I'm going to get is I'm going to get a series of values, one for each of these, where I'm just producing sort of inverse versions of exactly this equation. Because if I imagine that I'm talking about this square where like here's t0, 0, and like here's t1, 0 or something, and here's t1, 1, and here's t0, 1, right? Or something like that. Then I know that my fall off for t0, 0 is like uv, right? And I know that my fall off for t0, 1 is going to have the exact same v, but it's just going to have like 1 minus u. So the r0, 1 fall off is just going to be the exact same value, but instead of a u squared, it's going to be a 1 minus u squared, right? Because the distance away from t0, 1 goes the opposite way. Here, as u gets higher, my fall off gets higher, right? I drop my contribution. But as u gets higher here, I increase my contribution. So it's just the opposite value there, right? I think that's really all there is to it, right? So we're going to have something that looks like this. Oops. So here we have, I don't know why I keep wanting to do that. So we're going to have 4 different coefficients. Each one is just going to be the clamped version of the distance equation for that corner, right? And the only thing that's a little bit strange is we know that if we were to actually apply this literal equation, so exactly what I've written here, we would actually end up with situations where the brightness was not uniform. So the contribution of these would not sum to 1, right? So it would produce a radial blend, but it would not produce a balanced radial blend. And that's because, let's suppose we got to a position, and I don't know if like right in the middle would be a good example of where that would be. But there's probably locations in here, and we'd have to take a look. In fact, this might be a good case for me learning to use that Desmos program. We already saw it illustrate something very well once today. Let's see if we can't catch lightning in a bottle a second time. So if we go here, I don't really know how to get a new one of these, but I assume I can just do that maybe? Yeah. So if we were to take a look at the total power, so I'm going to blend 2 lights together, right? 2 lighting samples together. And, in the actual case, we're blending 4 together. But because I'm just going to want to graph one thing here, let's just look at just what happens along this line. So from t00 to t01, I could do, if we assume that both of these lights were like full intensity, the question is, what would the intensity be along the line? Now, if they're both full intensity and I do a bilinear blend, I know that's a convex blend. I know that it's uniform way throughout. So it would just be uniform brightness throughout, right? Full bright, and throughout it would just be full bright the entire way because you're blending from full bright to full bright. There's no delta there, right? But what would happen if I blend these 2 equations together, right? So what happens if I take and I say, and I have no idea how to use this program. Guess I would probably do a y equals. Does that? Okay. So I do a y equals, x is my variable. So x in this case is going to be u, right? And I say, all right, I want to take 1 minus the square root of u squared. Nope, where's that? Squared. Yep. So I want y equals 1 minus the square root of u squared, right? And that's my my distance function there, right? And this is going to be clamped. So I don't know how to clamp this. Of course, in this case, I guess if it's not radial, this doesn't do anything. So I guess I'm going to have to do something a little bit fancier, aren't I? Because if we just square root u squared, the distance is just along the line, and it's going to degenerate, right? We won't get any of the nice radialness there, right? Because, yeah, I mean, that doesn't really help us. I suppose I could do this, right? And then I would, because that's still the same. We don't have to actually do the square root in that case. But again, not sure that really helps us. We'll see in a second. So if I sum these two together, nope. There we go. So if I sum these two together, what you can see is the sort of thing I was talking about, right? Now, we'll take a look at what happens if I sum them the other way. But if you take a look at what happens if I just sum these two together, even though neither of them, either one, right? Because we're only looking at this cube here, the 1, 0 to 1. Neither one of them ever goes above the actual 1 point, right? There's the radial blend one way, and here's the radial blend the other way, and they both stay below the entire time. But because they are nonlinear through the middle, they can blend together to be higher, right? And so if I were to normalize them, right? So I would just say, look, there's the value. And when I take and I add these two together, I want to make sure that I divide by whatever the total value is going to be, right? So I do this. That's how we would get a constant power throughout, right? So I would blend this much of one and this much of the other, right? And I would normalize those weights by the 1 norm, right? To keep us always in line. And so if I don't know how to graph like other stuff, but you know, like if you imagine, nope. There we go. So if you imagine looking at the contribution of this, right? You can see that it has a kind of, because it's getting renormalized by the weight of the other one, you can see it using a kind of ease in, ease out curve almost now, right? Rather than a line. And similarly, if I graphed the other version, it would just be the opposite curve, right? So if I copy this equation here again, you'll have to forgive me. I don't really know how to use this program, so I'm kind of making it up as we go. Like it doesn't need these. I don't know. I guess I did it that way. The better way is to select and then hit the divide sign, and it knows what you mean. So that looks a little better. Right. So you can see the weights of the two of them normalized in there. Now, like I was saying before, I guess if I do the square root here, I'm not sure to what extent that really makes sense. But let's take a look at that. So if I were to duplicate this, I guess I just do that. Yeah, so if I were to duplicate that and just put in the square root version just so we can see, but I assume that it doesn't really do anything in this case because it just turns it into a line either way. So if I do squirt u squared, like so, and then squirt, again, really apologize. I just don't know how to enter things into this program properly, so it's kind of a learning experience here. Right. So let's suppose that I do the square rooted version. So this is the distance function version. And I don't know how to like turn this off. Okay, there we go. So there's another version of this that would show us what would happen if we just do the two opposing ones. Now that's a little bit weird to me. So I think I'm maybe, that's why. I'm like, shouldn't those both be a line? And that's just because I've, again, did exactly what I did on the board. There we go. No. Come on, make that a squared. How do I make that a squared? Oh, there we go. There we go. So if I actually do the distance, the non-squared distance, you can see that I just get the bilinear blend back, right? And so what I'm thinking is maybe we just don't do that. So we leave in the squared term, right? So we don't square root. We do clamp, right? We would like to clamp here, and I'm not sure how to get that clamp in there. So it won't look exactly like this if we clamp, because this, I believe, would include... Oh, no, we're fine, because we can't go over 1. So no, this is correct. This is the curve, because we're not looking at the diagonal. When the diagonal can get past 1, right, is where we get a problem, right? So like somewhere in here on the actual cube, on the actual square. But this is just looking at 1 along the radius. So this is exact. So this is what it will look like, even with the clamp in place. So if I were to actually compute these values, my argument is, well, at that point, I know they sum to 1. And once I know they sum to 1, I should be able to just produce the UV values, I think, that would produce the exact right combination of each of these things, right? I mean, that's my thought. Now, I don't know if that's actually true. And the reason is because there's 4 things involved here. And having the weights properly sum to 1, it may do it in a way. I'm not sure if you can produce all... No, I should be able to produce all possible combination. No, that's not true, is it? So I'd have to think about that. The question is, can I always produce the correct version of this, right? Now, I don't know, is there a way to make this, can we do fancier things here? I don't actually know. Like, I assume I can't do 3D graphs, but maybe I can. I'm not actually sure. It was cool that this thing just knew that if I used U, like, it's really cool that it just kind of knows. It's like, hey, I looked and I noticed there was only 2 variables, so I graphed them this way. So what I'm wondering is, if I was to make a 3D graph, would it know what that was? Like, suppose in here I said, well, you know, actually what I wanted was v squared. Right? Does it know? I guess all it will do is add a slider. So yeah, so I guess I can look at a 2D cross section of what's happening with V. I guess that's what I can do. How do I... Oops. There we go. So I can look at a 2D cross section of the answer, I guess, is how this works. By isolating a particular slice of V, right? And this will show me what the answer is specifically for just that curve, right? So like I said, the problem with this is unclamped. I'm not sure how this would help us. I don't know if this has any kind of functions like that. I could look, I guess. Maybe here. I don't know where this would be. I would assume that they would have something in there. Maybe not. I don't know. So I'm not sure if I can actually clamp one of these values. That's something that someone who knew how to use this program would definitely be able to do, and I don't know how to do it. What did the Octahedral one do? So clearly, like, there's, like, that's a function. So was squirt. So I guess it just, like, is there some way to list the functions, right? Like, how did this and this? This is like, looks like you can define your own. So we could make our own clamp. In fact, looks like this is a pretty cool program. It just, like I said, I don't know how to use it. So, like this part right here is an example. It looks like you can just create your own, like I could create my own clamp. You know what I mean? Again, I just don't know how to use it. So I won't do that at the moment. But it's pretty cool that you can do all that stuff. This is such a neat program. I don't know who made this, but it's pretty awesome. So anyway, and they had to make all this in JavaScript, right? Like, I think that's pretty good, right? It's not fun. So if you look at what's happening here, right, this is the part that I'm talking about. So the radial fall off, I just want to know, like, is it a line always or not? Like, but I'm assuming it's not if we normalize it out. I'm assuming it actually has some shape to it, right? And you can see that if v equals 0, at the v equals 0 point, it does actually look like a line, which is a little bit strange because I would have assumed that it would not, since in theory, if v is knocked out of this equation, it should look the same as this one, right? So, because this is the, yeah, no. Oops. So there we go. Okay. So that's actually more what we'd be looking like. So if we use the squared fall off, right? So there's the squared fall off curve. And again, like, I think this would be incorrect because it's not clamping where it should be clamping, right? So when it gets down to 0, and this is not right either. There we go. So when these values, as we do this, they're incorrect because the clamping is not actually in place on either the numerator or the denominator, right? So although we're properly now seeing what happens in the case where v is not allowing you to push over 0, because when v is 0, then this equation does not need clamping. But once v becomes larger, then it does need clamping. And it would be nice to be able to see what was happening there with the clamping. I wish, is there no clamp function? So it knows abs. Oh, it knows min. All right. Well, so if we took the maximum value of that and 0, I mean, if that's actually working, that's a clamp, right? Because we don't really need to clamp it on the high side. Even if we did, we could choose a min. We just need to clamp it so that it doesn't go below 0, right? So I don't know if this is right because I'm not sure how to use the program. But we're going to give it a shot. Possibly. I mean, maybe that worked. I really don't know if it did or didn't. So that doesn't seem particularly logical to me. It doesn't look like that's actually clamping. Because I'm not sure where you would be able to get those errors in there. If I'm at, like, I shouldn't ever be able to get a 0, should I? Like, that doesn't really make sense. So it's a little bit confusing. Like, I think I probably did this wrong. Oh, you know why? Because this max is in the wrong place. I mean, I could do it this way. It'd be a min. Yeah, so that's wrong. It's this way. Sorry, again, this is pretty confusing for me. Like, I don't really know what I'm doing here. So I'm like, as I'm thinking it through, I'm just kind of putting things in. I'm like, wait a minute. No, why are you doing that? It's not the math you actually wanted. Okay. So if I say, look, the maximum of this in 0 here, and let me put this one in the same place. So there we can see the normalization a little bit more. I still don't know if that's really working the way I think it should be. Because it looks like that. I don't know why that would, again, create any kind of a divide error. It shouldn't if I'm doing this right. So we take the maximum value of whatever this is. We want to clamp it to 0. So once this gets above 1 and this becomes negative, we should be taking 0. Right. And then we've got the other one in here. Oh, so I guess that's, yeah. I guess when we think about that, so when you're doing the V, the problem there is that we now we don't have the other 4. We don't have all 4 people who should be on the bottom with a V. So that's what we would expect, because normally now what we would have is we'd have the other 2 in here, right? So in addition to the previous ones, we would also have 1 minus V and 1 minus V. So it would actually be that, right? Is what we would have. So yeah, I guess we wouldn't really have that problem, right? So that would prevent us from ever getting a 0, I think. Right. And so that does give us what I would expect. Except at the 0, okay, so at -1, it's still not giving me what I would expect there. Right. It's hard to see this, can I? Yeah, I can. So at -1, that would be, you know, this should, I guess, always be, this would always be 0, right? And you know what? V can't, I don't know. Yeah, so that's actually just wrong. This can't be -1 anyway. So it's really just here. All right. So there's the blend. And it looks a little wonky. Like, you can see that there's a weirdness there. So let me just take one more look to see if I've got something that I think is actually correct now. So 1 minus this is the squared fall off here and clamped. This is the squared fall off, yep, and clamped. This is another squared fall off and clamped. This is another squared fall off and clamped. Right? I mean, so that looks like it's correct. The top one, again, is also clamped because we don't want to consider any contributions that are too high or too low. Yeah. So if that's actually accurate, I don't actually need these intersection points, so let's get rid of that. And let's take a look. So kind of what you see there is it's not particularly compelling, right? Like, it's all right, and it has some of the properties that I might want, but the fall off is not really what I would have preferred, right? It's kind of got a nasty, like, I don't like those discontinuities. Like, I'd like to see something that had a little less discontinuities in it. And the reason it has those discontinuities is because of the maxes, right? Those create sort of hard breaking points. So I guess what I'm wondering is, can I make it so that we actually just maybe make the fall off across the entire thing? So maybe I just say, look, all that work I did to figure out how to maybe make max work, and hopefully, like, I'm interpreting this correctly, right? But maybe what I should do is say, no, let's actually not introduce any discontinuities there. Well, let me leave this on the thing for now. Well, actually, I guess I don't really need to. So let's get rid of the max. Not the Boeing 737 MAX, of course, the wonderful airplane that crashes into the ground due to software failures. Let's get rid of the max. So we just have the terms on the bottom. And all I want to do is say, look, all right, when we actually drop this down, I want to take and I want to add the root 2 term in there, right? So meaning I want to take out, I want to basically put in a thing, and I don't know if I can do this, but let's suppose I took like a scale value and said scale value equals 1 over square root of 2, right? So basically reducing that ability, so because I know that as I square that out, right, like as this squared value comes out, my scale value, I know that the distance, the radius that I want this thing to get to would be root 2. That's the distance along the total distance along the diagonal of the square. And this is actually the squared distance here, so I believe it would just be actually the square of this, right? So it would actually just be like 1/2, right? So if I were to actually put in the 1/2 term there, I'm wondering what that would do to my equation. I mean, I'm just curious, right? Just to see what happens there. And I guess, so I must have messed that up a little bit in my head. Let me actually write that out because it looks like I'm wrong about that. But point being, the scale value, like whatever goes in here. I'm just curious what the actual answer is. Yeah, so I don't know. We'll take a look. But anyway, that may be more like what I want, right? So let me just get the scale right on that. But I think that may be what I want, because then that way, if I actually make these functions well behaved in there, I can get a curve, and the curve won't actually be discontinuous. I'll actually have one that can step properly through itself. Now, one thing I don't love here is I don't love the rapid fall off here. I think I would prefer something shaped more like that. So I might continue just the shaping of these here and say maybe what I actually want to do is make it so my fall off curve is something slightly different. So what would happen? I really need to learn to use this because we could probably make functions for doing this so I could change these more rapidly. But what would happen if actually I wanted to do, like, let's start over. I'm kind of into this now. So let's say I've got uv squared here, right? And what I actually want to do is, before I was doing the fall off this way, right? So we start at 1 and we drop down like that, right? And if I do 1 minus like u squared v squared, right? You can see as I do that slice, it's pretty clean, right? It looks pretty nice. So the problem that I'm getting is when I add that normalization in there, and I don't know if this thing supports. Oh, it even has undo. Man, this thing is amazing. So the problem I'm getting here is, like, if you see what happens once I introduce the normalization, right? And it doesn't matter whether the S is in there or not. So no matter what the S is, right? So I can figure out what the S is just by trial and error, right? And I just need to figure out what actually... that's... Okay. That's the problem right there. So I should be able to figure out some way of taking these values. And I guess, you know what, now that I think about it, this S, since there's a 1 minus in here as well, I suppose this S even has to probably happen beforehand. So it may not be able to, no, but it should be able to be pulled out. Hard to say. So I need to make this equation so it operates across the square so I get an even interpolation on it. But either way, once I add the normalization, you notice how I get a curve that drops off like this? And I was kind of hoping for a curve that dropped more like that. And I guess the problem is I'm not sure how I would actually do that in a way that actually has the sum to 1 property. So we do have a bit of an issue there, and I'm not sure how I would really go about fixing that. But let's just take a quick look over. I'm going to switch over here and see how I would get this to come out to be properly radial. So if I assume that I've got my square here, and I want to make sure that this point right here is actually the 0 point. You know what, though? Thinking about that, that doesn't work, right, either. Because if we did that, then we would have to use those values out here. So we pretty much can't do that. We do have to just clamp in there. Like it has to clamp and get down to 0. I mean, we could use negated, but again, then you would have the same problem. When you cross this line, you would get a discontinuity. So I don't know. It doesn't look like there's any way to avoid that kind of wobbly shape to it, right? And the wobbly shape comes because when you hit a place, you know, you're basically going to have, for each of these, you've got a circle, right? And each of these circles creates a discontinuity in the interpolation, right? So you have different places where their clamping would kind of max out, right? And I don't really know what to do about that part, right? I don't know what to do to fix that. It's a little dicey, right, to figure out how we would actually... I'm assuming we would see that as well. So we would change the interpolators to have, instead of this diagonal cross problem, we would spread it out so that it's actually at 4 things instead of 2, which I'm hoping would give us a nicer interpolation. But at the end of the day, there's still a discontinuity happening there, I think, that we would see in the interpolator. And I'm not sure, I'm not sure what I would do to get around it. Either way, let me see. I want to know if I can hack something in to allow us to sample this. And the problem is just figuring out how we're going to do it. So I think what I will do is I'll use the way I was suggesting originally just to make sure that I can play around with it a little bit easier before I try to do the UV solving. So rather than doing it this way, I'm going to actually do this, right? So we're going to try and take an RGB sample, and I'm going to produce that RGB sample by taking a sum, right? So I want to literally do exactly the thing that I said. I want to do literally this, right? And I want these to all be computed based on the fall off. So I want to do that fall off. And then I need to actually produce these values, these textile samples. And producing the textile sample is going to be the hardest part by far, right? Because it's a finicky, discrete lookup kind of operation. But so in here, I want to go ahead and produce these C values. I know I'm going to have a UV somewhere here, right? That's the offset. And what I need to do is for each of these, I have to produce that UV by figuring out what the actual equation would be. And like I said, what I want to do here is say I want 1 minus clamp 0, 1 of some equation in here, which is going to be something like, square U plus square V. And so what I might do is actually, to make this easier on myself, just do that. okay? And so each of these is literally just going to be the exact same equation, just with different things put in here. Then we're going to have to make a denominator, right, out of these, which is literally just going to be like C00 plus C01 plus C10 plus C11, right? And we're just going to invert that. And we know that unless we really screw something up, it can't ever be anything other than a non-zero. Like this has to be a number that's either like that's close to 1, right? It's never going to be 0. So then we just have to multiply each of these like so. And then we can do our like conservative interpolation. Now, we don't have to normalize them to 1. We could let the powers range, and we'll take a look at what that looks like, right? We could try just turning that off and see what the interpolation looks like that way. If it's not conservative, it's not conservative, right? We don't have to make it be conservative, but I'm assuming that we'll get worse results if it's not. But we'll see, right? And furthermore, we could conserve it in other ways. Like there's other things we could do to those equations, so we have to play around with it. So for each of these, if we assume that the first value is u and the second value is v, right? Then in this case, the u is going to be 1 minus u. And in these cases, it's going to be 1 minus v, right? But that's it. So that's the entirety of what we're doing. We're just taking the clamp of the squares like so and producing those blend values. So that's just like a radial fall off on this thing. Now what we need to do is say, okay, after we do the radial fall off on it, we need to actually have something to blend here. So we need like the basis UV, and then we need the like offsets towards the other values that we're actually sampling. So we need to figure out how to sample this thing. And in order to do that, we're going to have to use that texel fetch function. So if we go and look at here, what we want to do is this texel fetch. So we want the one that's going to take a 2D sampler and a 2D point, right? And the LOD is always 0. We're not doing MIP mapping here. So we want to do a texel fetch call. We want to pass it the light that we're actually talking about. So light color sampler, the map that we're actually talking about. We're going to take the IVEC that we want to sample into, and that's just going to be like our UV. That's our literal IVEC. So this is our UV. I guess what we should call this is our UVI, like our integer version of this, right? And then for each of these, it's really straightforward because we're just passing in for each one of these. We want, and do we have a V3U? I don't know what we've got here, or V3S. I don't see that in here. So I'm assuming we have to actually use an IVEC3. So for IVEC3, I'm just going to say like we've got that. For IVEC3 and IVEC2, I'm just going to say that that's like V2S is an IVEC2, right? And V3S is an IVEC3. You know what I'm saying? And the same here. And that will just let me notate it the way we're used to outside in Handmade Hero instead of having to adapt to OpenGL's like nomenclature for no reason. So if I want to, I can just say, all right, so we've got an offset here that we're going to apply. Actually, I guess it's a 2S in this case because we want to do a 2D sample. I want to do this one, right? So I want to take whatever the base is, and here I'm saying that I'm going to do a V offset. Here I want to do U offset, and here I want to do both. So that's fundamentally what I'm doing. Here my U and V, I know that I've got effectively a UV that I'm trying to sample, right? What I need to do is find out how far away I am in sort of the texel space, right? I suppose this was possibly a bad name. What I want to probably do is like texel, right? Or something like that. So I suppose what I want is something more like that. And in order to get a correct answer here, what I want is like T minus TI, like whatever my actual value was. So I want to basically upconvert this to an F32. and subtract. So when I have the actual integer location that I'm sampling at, I want to subtract away however far away I am from that integer location, right? So this is the way that I would do this blending. And in order to figure out what the heck is going on here, right, because we've got so much happening in here, another thing that I could do and maybe will do is just try to duplicate everything first. So if I inside here said, don't do that, let me try to just produce the linear interpolation values first. Then what I could do is actually have each of these. I could have each of these be the linear interpolation value that it should be, and I should be able to try. I should figure out how to match OpenGL's result first, right? So in other words, when I have this set to 0, and I compile, right? Unless I have a bug, I should get, what I'm looking at here, right? I should get this. And so I should be able to swap between these two. And if I produce the correct linear interpolation values, I should get the exact same result. So what I want to do is make sure I can match OpenGL first so that I know I'm not screwing this up. And then we can look at changing the coefficients to see if they produce anything that's more satisfying, right? Okay, so if we then think about what these values would have to be, so we essentially have an interpolation across U and across V, and so we know that each of these is just going to be a multiplier of those two values, right? So for C00, it's just going to be like 1 minus U times 1 minus V, right? Because if I'm at U0, V0, I'm just at my current location. And as I move away, I'm going to lose contribution in both U and V linearly, right? So the same would be true here, except the V is going the other direction. The same would be true here, except the U is going the other direction. And then in this case, neither are going, right? So it's both. It's the different direction in both of them. So I think that would be the correct way to do the blends on these. And let's just double check really quick to make sure. So if you think about how this blend is going to work, you know exactly how a bilinear blend works. If I'm bilinearing between these, and we're saying that this is T00, this is T01, this is T11, and this is T10. So if these are my points, and I assume that V is going this way and U is going that way for my two parameters that I'm blending, all I need to do is say, all right, what are the bilinear points that I'm first going to do, let's say, along U? So if I want to produce these 2 points, and we'll call these 2 points T1 and T0. So what would T0 be? Well, T0 is going to be 1 minus U times T00 plus U times T10, right? And similarly, T1 is going to be the exact same thing, 1 minus U times T, but now instead it's going to have this value is going to be the upper Y, right? So instead of 0, 0, it's going to be 0, 1. Instead of 1, 0, it's going to be 1, 1, right? So those are my two values here. And then I need to blend these two together, right, using V. So then my final equation for my texture sample, in this case, is going to be 1 minus V times my T0 plus V times my T1, right? And if I now go and look at what this multiplies out to be, I can just substitute these two values into here and see what my terms end up being, right? So if I take T equals 1 minus V, right? And here's my T0, it's that. So I've got a big paren, 1 minus U, T00, plus U, T10, right? And then I add again. Now we've got a V multiplying in here. Big paren, 1 minus U, T01, plus U, T11, right? So if I see now what I get my terms to be, you can see that they're all lined up nicely, like they each have just a distinct location. I don't have to combine any terms here. So if I want to know what multiplies t0, 0, well, all I have to do is just finish the distribution. 1 minus v, 1 minus u, t0, 0, 1 minus v, u, t1, 0, v, 1 minus u, t0, 1, v, u, t1, 1. And hey, that's exactly what I wrote down, right? So t0, 0 in this case is 1 minus u, 1 minus v, exactly what I have. 1, 0 in this case is u times 1 minus v, exactly what I've got. T0, 1 in this case, which is this one, 1 minus u times v, that's what I've got. And then uv, which is what I've got. So again, just making sure nothing funny is going on there. This is what I would expect the result to be. And so now if I enter this path in, what I need to produce is the actual input values, right? So I'm going to need my t value. I need that to be equal to something, right? And then I need, my s, my integer version of that, to be produced somehow, right? So this is my actual texel index, which involves actually knowing the size of the map. And fortunately, I think I can get that without actually having to know what it is. Although I think this actually tells me some of that information, right? Because I could actually compute the total size of the map. So I guess I don't need to look it up. But hey, it happens to be in here anyway. But yeah. So anyway, if I want to actually produce these values here, if I'm trying to look at where I was going to look up, you can see that this here was the UV that I actually was going to use. So in theory, I should be able to really just do CUV times this exercise should give me that, right? So actually, I could just use this directly and produce that value just out of hand, right? So I should be able to say, look, it's the V2 of the texture size of the light color sampler, right? And the LOD level 0, that should just give me what I want. Also, these texel fetches, I guess, need LOD level 0 in there as well, right? So if I just produce that, that should in theory be my t value, and then this would just presumably be the floor of t, right? Because I'm assuming that's what the graphics card is going to do. I mean, right? It's just going to multiply out by the size, then it's going to floor it, and it's going to use that as its interpolator. So let's debug that, and we may have some errors in the shader now, so we may have to field we may have to field some fragment errors. You can see we've got some implicit cast errors here from vec2 to ivec2, right? And so I'm not sure what exactly we're getting as a problem there. So it could be the floor function is creating a problem for us there. Looking at the texture size here, I'm assuming that's okay. The sample to, like, these are all continuous. So I guess at the very least, this is probably not good. So when we do this floor function, we probably have to then convert it to a V2S, I'm guessing, but I'm not sure. Then also, you know what? These are all incorrect as well, I guess. So that's probably where that's coming from too. These are producing 4 wide and I only want 3 wide, so that's also an issue. So let's go ahead and stop the program here for a second, do a quick recompile and see where we're at now for errors. So we have sample RGB and C11. So it looks like I just accidentally capitalized the C value there. So fix that. And then the sample RGB, we don't really need that. That was a waste of everyone's time. Off we go. So now I think we're okay here. Not 100% sure. Let's see if this has any love for us. It does. So if I hop over to the same area that we were in before, which is up here in the large room, just so we can see a little bit better. And I think I was kind of hanging out in the middle of the large room. So if we look at that interpolation, is it exactly the same as OpenGL's? I'm not sure. Let's flip it. But it looks close, right? Like we're not totally screwed. So let's see what OpenGL does. So it looks like we're sampling, it looks like we're just sampling a little bit slightly wrong. Like it looks like maybe we've got a 0.5 somewhere we shouldn't. So maybe we're just a little bit off in terms of how we're interpreting these values here. I'm not sure. trying to think of what would be causing that problem. So if it's going to do a floor function on the value, it probably does have a 0.5 offset in it because it's going to need to take for the edge. So at 0, 0, it needs to actually be sampling to that value for the entire way. So I think it probably wants to actually look like 0.5. Let me just draw this out. I think it wants to look 0.5 back. Let me explain what I mean by that. So if you take a look at the grid, right? Oops. So let's suppose this was our texels. You know what I mean? So if this is actually texel 0, 0, or you know what? Let's make sure we're the right way around. If this is texel 0, 0, so V goes that way, U goes that way. So if this right here were texel 0, 0, then actually the bilinear wants to start here, right? Because it's actually, I believe, it does centers. OpenGL's texel ideas are not my favorite sometimes, so I'll say that. But I believe this is how it does it. So right or wrong, this is how it's going to do it. And that means that if you were sampling like right here, you want to start with this one. But also, even if you're sampling all the way up here, but we would start with that one. So I think what we actually want to do is subtract that 0.5, 0.5 to drop us down to the previous one. So I think we actually want here, where we do this, I think we want a drop here so that we actually move back by a half a pixel. Well, I guess... No, that's correct. And I guess this wants to be in there, right? It's not part of the other branch. So if we take a look now back at the game, let's see what the difference is now with that half pixel sample. So looking at it here, this is the OpenGL one we're looking at. Now we're going to switch to ours and see what the difference is there. And that looks exactly the same to me. Right? Like, I don't see a difference there. So, I mean, it doesn't, I can't even tell when it changes. That's how exact that appears to be. So I'm going to call that good enough for government work, or stripe debugging. And we're just going to like, now see what happens if we change those interpolation parameters. So here's us playing with the interpolation parameters, just willy-nilly, right? And now we got to change, what's this? Right. Sorry about that. No, stop. All right, so in here we've got these duplicative declarations because this was supposed to be an else, and we didn't actually put an else in there. So we actually need that, right? All right. And so what you can see is it did effectively exactly what I wanted, right? Excuse me. So I was looking for a radial. I wanted a puffy fallout, right? That's what I said. Puffy fall off. And that's what I did. Like, I put in a radial fall off and I got a radial fall off, right? So you can see the difference very clearly. Like right now, it looks more like a light kind of a fall off. And if I go in here and I change it back to using the OpenGL default version, which is this, you can see that it gets that line again, right? So there's the line. Now, I don't know which one of those is better, like I said, but it was an experiment I wanted to run. So what I want to do now is go back to the previous way we were sampling these just to see. And you can see, like, actually, I guess I don't like that, right? Because that still looks nasty in there, right, as those things overlap. So when I actually put real lighting values in here, quote unquote real lighting values, I don't know what I'm going to find, but I want to know. So I'm going to try turning off the sort of structured art that I put in there just to see what happens if we take a look at the interpolation here. So if I now go back to the original and I just turn off the structured art in the textile sampling, so now it's actually filling in real values. So here are those lights. What you can see is that, you know, you still perceive them, but I guess I might say I do already kind of like that interpolation a little bit better, right? We might be able to do better than that, even better than that, by thinking about that interpolation a little bit more. But if I now go in and change my OpenGL side of things back to linear, right? So in here where we were doing our light, I don't remember what we called that. It's like light filtering or something. Where did that filter go? Oh, it's already set to linear. Never mind. What I mean is in the shader, I should stop clamping the thing. So I was in the right place. I don't know why I left. So in the shader, if I stop clamping, so if I turn this off here, so we're actually interpolating across the voxels now, this is what we would get, right? And yeah, like again, I don't know. I think I would probably say two things. One, I'm really glad we spent the time to look into it because now we know exactly what's going on there. It's the interpolation between neighboring octahedral samples that's producing that result. And so we just need to be aware that there's a cost there and there's a quality issue there potentially. I do honestly think the puffy one makes it look more light-like, more like lighting. So it may be that we want something like that in there. I'm not willing to call it one way or the other just yet, but I would say, you know, it's something to consider. So let's go ahead and add in the full lighting now. So rather than just doing a direct, let's do the mod. And I would say, you know, we're in pretty good shape. Like, we're starting to really have something here, right? Now, we have a lot of work to do because now we got to put in our bounce lighting, right? But I don't know. I'm feeling pretty good about it. There's a few things I want to look at, but I mean, it's looking sweet, right? I mean, I'm pretty happy with where we're at. All right, so let's go to a brief Q&A. How do I make that happen? There we go. So let's go to a brief Q&A. I'm pretty happy with that. So DevSigner wants to know, why is the lighting behind the character so dark? So the reason for that is because right now, and this is somewhat intentional because we're trying to test, right now we are doing specular only. So actually what you're seeing here is only light that bounces and then hits the light source, right? Now we can do a diffuse lighting sample as well, and we probably will want to going forwards. But at the moment, we're only sampling in just that one direction. And that's intentional because I want to be able to see how this lighting is getting sampled specifically. If we were just doing the diffuse sample, it would be much harder for us to kind of debug these octahedral maps because we'd be taking a very blurry sample from kind of a much wider part of the map. You know what I mean? And it would be hard to find bugs. Does that make sense? For a look at Desmos calculator. Okay, we can take a look at that. Hold on a second. So slash 2yexoy zdk5. So someone has built an instructional one for us, which thank you very much. You can assign and use functions throughout the graph. The clamp function uses conditional true false. Okay, so basically curly braces are a way of producing two different things depending on a condition, I guess. So if it's less than 0, put 0. If it's greater than 1, put 1. If it's neither of those two things, I guess put u, right? So it's if, and then the final one is just the catch-all, I'm guessing. So as far as oh yeah, that's great. Yeah, that's cool. Yeah, that's great. So perfect. I mean, right? Exactly what we wanted to see. So, okay, so I get it now. I'll do that. And then once I define that function, I guess I can use it anywhere I want, is the idea. Yeah. So that's pretty cool. Okay. So I'm going to put this here. So the next time I try to do this, I'll refer back to this. Can I rename this probably? So that way I can just click on this and look at this again and remind myself so I can create those functions a little more easily. So thanks for sending that in. Synthusiast asked how fast this lighting method was if we compiled in debug mode. Probably not very fast, but you have to remember that the code is really bad right now. We're doing a lot of things we don't need to do. So actually, I don't think this code is going to be that bad once we actually streamline it. So I think it will be fairly fast in debug mode, but at the moment, it's not going to be great. Jesse Meyer says, I have to say that your debug videos are often more educational than implementation-heavy ones. Very insightful into your process. Thanks. Yeah, well, I'm really glad that it comes across because, again, I think the primary thing that you need to learn about debugging is that tenaciousness of like find out what's actually going on, right? And it's so rare right now. And I'm kind of like, I would say I'm fairly light on that side of things actually. Like I'm about the minimum you would want to be in terms of that tenaciousness. So like if anything, you should be more like what you see on stream is the minimum you should ever do. Right? So if you're actually a diligent programmer, you should actually probably be going further than I'm going most of the time. And that's both because I'm more of a broad spectrum programmer. I don't actually tend to rat hole on things for years, which, you know, some people might do. Like they might be like, I'm going to work on compression for 5 years, right? And that's great because they will come up with really cool compression stuff, right? But I tend to be more broad. I do more things less deep. So there's that. And also on stream, it's limited. I can't spend 16 hours looking at something in a row, which is what I would normally do, right? Like 2 days in a row, 8 hours a day or something, looking at something. I would do that. I can't do that on stream. So I would say the minimum, you know, what I'm doing on stream is a minimum of tenaciousness I think you should apply. Is octahedral lighting the only way to go for what you want? I don't think it's the only way to go. It just seemed like the best one. I liked it a lot better than spherical harmonics as an option for us. We didn't really look at spherical Gaussians, but I'm assuming I would have similar complaints to harmonics. So no, it's not the only way to store lighting, diffuse lighting over time. I shouldn't say diffuse only, but inbound lighting. It's not the only way to store low resolution inbound lighting over time. Once you take depth samples, could you do bounce lighting by fetching the depth sample and then moving that far down the normal to seek directly to the next voxel? You certainly could do something with that if you wanted to, but in our case, I don't think you ever need to, because the whole point is the bounce lighting is getting rolled into an actual, into the actual probes. Right? The bounce lighting is going to happen in the distribution phase. The whole point is we don't want to spend the time to do bounce lighting inside the pixel shader, right? Because it's too expensive. So instead what we want to do is just have the probes over time send the light themselves around so that we get the bounces that way. Right? Wait, there's something wrong with this? Oh, this still looks right to me. You're saying this is no longer, this isn't the right one? I'm so confused. It looks like the right one to me. You're saying it's not the right one? So we actually have to edit this bookmark? What should the bookmark actually be? QMEPHGC1P5. That looks the same. I think it's fine. Could you do a stream on RAS telemetry one day showing all the things you can do with it? I'm really interested in the tool, but the only good video source on it is John Blow, but his streams aren't very tutorially by nature. Yeah, I mean, I guess the way to think about telemetry, though, is you don't really need me to do a demo. It's just, you know, our profiler where you can see all the threads and you can click on the threads and see what each thread's doing and drill down into it and all that stuff. Telemetry is just a professional version of that. I mean, that's what it is. So basically, like, it's a standalone tool, so you don't have to integrate it into your game or write it like we did. And then all you do is in your game, just like we have blocks, you put in blocks for telemetry. And it will just send them off to the tool, and the tool records them and saves them to a file. And you can scrub around in them just like you can in our tool, only with better UI, right? And you can do a bunch of things you would normally do on there. So like they'll capture more inherent stuff like kernel thread switches, or like they'll use event profiling on Windows to like capture extra stuff like GPU information. So just imagine like the professional version of what we did. That's what it is. So, you know, if you want to be able to inspect the performance of your game or whatever, it doesn't have to be a game. That it's just, you just buy it and then you're done, right? So Philip Trudeau asks, with the octahedral map, both the bilinear filtering and the puffy filtering seem to have a pretty quick fall off between samples. Would you consider doing something like bicubic filtering for a smoother blend? Yes. The reason I wanted to not do a cubic blend is because that involves taking more samples, right? So what we could probably do is take we could probably try taking just 3 samples. You know what I mean? So one way is to expand it to 5 samples, which would be a lot. That would be a 25 tap to the texture, which seems nuts. Like, I don't think we're going to get away with that per pixel. I mean, maybe. I don't know. But another way would just be to expand it just to 3. So instead of a bilinear filter, there's just one more. So we just look on the opposite side as well and fit the curve through those 3. That might work, right? And I don't know. But yeah, like I said, what I wanted to know was what's the... Like, basically, I wanted to know what the artifact we were seeing was. And now I'm like 100% certain I know what it is. And that's good enough for me right now. I do think we might want to spend more time thinking about what we should do about it, right? Because that I'm not sure about. But now that I've played with it and I tried putting in a replacement and I saw it change as I expected it, I'm fairly confident that I'm not like totally clueless about what's going on. Whereas when we started today, I just didn't, you heard me say it, I did not feel like I understood what was going on, and I don't like that, right? I want to know what the artifact is. Do we have a bug? If we have a bug, how bad is it? If it's not a bug, is it something we could improve anyway? Because maybe, like in this case, it wasn't really a bug, as far as I can tell, right? It was actually operating properly. But it's still not great. And now that we know what it is, we can ameliorate it. I think we did some amelioration. I think it's actually better now than it was. And we might be able to do even better. But at the moment, I'm satisfied just knowing what that is. And so as we work through the lighting and finish up on the lighting, I'm not going to have to constantly wonder what the heck that thing is. I'll always know, and I'll know how it should behave. So it won't be affecting my ability to judge the quality of the light solution, because now I just know what that artifact is, and I can always just mentally account for it. Whereas before I knew what it was, I don't know what's going on in there, right? Who knows why that's happening, right? So it's really important to get that understanding, because now I can move forward without even fixing it any more so, and it won't negatively impact what we're doing. And at any time we can choose, if we have a good idea or we want to start just playing around more, we can always go back to it at our leisure, right? Do you use any equation for the light density attenuation? I guess I don't know what a light density attenuation is. Do you just mean the light getting dimmer as it gets further away? Or like density is throwing me off in that sentence. Do you know if RAD has discounts for students? No, I don't think they do. I do think they negotiate license prices based on the customers usually, and how many things they're buying, or, stuff like that. But I think pretty much the price is the price, more or less. I mean, it gets cheaper if you're site licensing and stuff, but... So as enthusiasts, yes, there isn't distance attenuation. So you can see that we've got a radial fall off on the light here. This is not the real lighting. This is just a specular bounce with radial fall off that we added in there. And that's all it is, right? For testing. So, because all we're trying to do is capture light into these probes and make sure it's working properly. And later, we'll actually do the work of putting in the light equation we want, because that's totally separate, right? The actual capture and persistence of the lighting is a separate problem from what you actually want to do with it. And so I'm not even really considering those at the moment. Would you ever go back to Rad? Yeah, I love Rad game tools. I mean, if I can't support Molly Rocket from sales of our stuff, it's where I would first look for a job. I mean, it's the best place I've ever worked. It's also where I send everyone. Like everyone I find who's like a good programmer that I see like on stream or whatever, I send them to John or to Jeff, like pretty much period. So they either go to, I know that John looks for people sometimes, so I'll send him someone or I'll send him to Rad. Does the paper from NVIDIA about octahedral sampling cover the sampling filter, or do they just use linear and bump up the size of the bitmap to have more samples? So it's funny you should ask that, because I was wondering that myself. I would like to look. Here's the thing. I remember when we were reading through it, they definitely did complex filtering on the voxels. And the reason for that is because they wanted high quality results with sparse voxels. So they wanted to do stuff like handle like voxel to voxel occlusion and all this stuff. So the voxel blend, they do a bunch of stuff. I remember seeing that. I don't remember seeing anything about how the octahedral map gets blended together. And what you have to recall, you have to keep in mind throughout all of this, is they're only trying to solve secondary bounce distribution, because they are actually counting on you doing a light map pass first to do direct illumination, right? So either actually ray tracing or doing a light map pass, they expect you to do one or the other to compute the direct illumination. So they're only concerned about secondary bounce. My assumption is they never would have seen this artifact, because once you take out the direct illumination and you're only looking at the secondary bounce, I would kind of assume that this gets swallowed up in the noise. So my guess is they never saw this. That'd be my guess. Now, I could be wrong. I don't know. And was very curious myself, so I think I'm happy to go look to see. Because I am interested to see what the answer is to that question. So you can see here, like, they use shadow mapping for direct illumination. So the direct illumination is just not in the mix, right? So this is all just about the probes themselves, right? So I don't see any discussion of how they actually sample the octahedral map. Right? So I'm going to go ahead and suggest that maybe they just leave it as it is, right? So here's the actual sampler. And I don't know, or at least might be the actual sampler. No, that's not it. So actually, no, I guess we don't have the shader here because that's just for updating the irradiance field, right? Isn't it? So here's them pulling out of a G buffer. This is like a deferred renderer. Here's the normal position, ray origin. Here's the 8 probe cage. So here's the actual sampling. So there's the direct texture lookup, right? So I guess I'm not entirely certain. It's only taking red and green out of here. Oh, you know what? This is the depth map, maybe? Okay, so here's the actual color lookup, and that's a bilinear, right? So yeah, they're just straight bilinear. Which, by the way, when we're done, might be the same for us. Like I said, we might not need to do anything about it. I just wanted to make sure we knew what was going on. When doing game logic, do you think it's ever a good idea to write in async await style and have that transformed into a state machine? Not really. I mean, not exactly that way anyway. So async waiting kinds of stuff, I don't think is the appropriate model for game logic. And the reason is because it's the same reason as you don't really want to do it for the way that people do it in like JavaScript for web pages. What if that condition never happens? Right? So a lot of times when people write code like that, they go like, oh, I want to write, the code for this AI or something. And it's going to go like, chase the player. And when you reach the player, then do this thing. And then it never reaches the player, right? So it's just in this weird state. So I think usually what you want to do are things that can remember state, so they can remember the fact that they are trying to reach the hero, but that every frame reevaluate whether that's still a good idea. And this is also why I think most web pages don't work, is they're written to assume a very specific set of things will happen. And invariably those things don't happen because a packet gets lost, or the user clicks on something in the middle of it, or who knows what, or the browser blocks a cookie. And then the code just falls apart because like 6 different async things are all waiting on different things and none of those things happen, or only 2 out of the 6 things that need to happen, right? So I think you want to be more defensive in your programming. I think you want to generally assume that while you can write something that transforms things into state machines if it makes it easier for you to program them, you want to program those state machines so that they actually take into account all the states that might occur. And I think one of the problems of writing async style code like that is not so much that you couldn't write obviously you can write either piece of code either way, but you should not be assuming that things happen in a series of steps that cannot go wrong, right? So if you do want to go the async programming route, at least make there be ways of which the async thing will have sort of exceptional things happen to jump you back to a known good state after a little while, or like don't just write it assuming it will work, because it never does. I don't have much thoughts on the ML family of languages. I don't tend to like pure functional. I think functional programming has its uses, but those uses are limited. And so I think it's better to have a language that supports both procedural and functional as equal citizens, rather than preferring functional. And if you're going to prefer something, you should probably prefer procedural over functional, because procedural is more flexible. And it's how a computer works, right? Computers aren't functional. Tagged unions are great. I use them all the time. Do you know about the inverse distance weight interpolation method do you think can be used for games? I'm not sure exactly what you're referring to. Obviously, we were doing inverse distance weight interpolation, but maybe you're talking about a specific method. What do you think of C++ 20 modules and separately of constant pressure? I don't follow C++ anymore. It's a disaster. It's a horrible language. It's one of the worst languages. Throw it out. Burn it. Doesn't matter. It'll never be good, ever. It jumped the shark before it even got in the water. It's over. Doesn't matter. Haven't even looked at them. Sure, they suck. I've only really focused much on Python, and I'm going to learn another language. What do you think of Golang? Haven't really done anything with it in particular, so I couldn't tell you. All right, I'm going to wind it down. Thank you, everyone, for joining me for an episode of Handmade Hero. It's been a pleasure coding with you, as always. If you want to follow along the series at home, you can always pre-order the game on handmadehero.org, and it comes with a source code, so you can follow along with it at home. I will be back here tomorrow when I think I will probably start putting in the bounce lighting. We also may want to see what we're going to do about diffuse. So we may want to start producing a low-res map as part of our downsampling scheme so that we can get some diffuse lighting in there as well. We have to kind of think about how we're going to do that. But we are going to want to do that eventually, because we need to have, our surfaces have to have diffuse and specular components to them, so we have to kind of think about how that's going to happen. All right. Hope to see everyone back here for that. Till then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.